Let's talk about arrays in C++. Now, arrays in C++ is sort of like the fundamental built-in type that we can use in order to store multiple of the same type of value. And what I want to talk about is what that looks like in memory. So I have my RAM here, and I want to create a new array. The syntax for this in C++ looks something like this. Int a brackets, and then how big you want this to be. Let's call this 5, right? I want to create a new array. It's called A, and I need to have 5 elements. Now, these are going to contain integers, so 32 bits, right? So a really good question is, how much space is this array going to take up in total? Well, it's the size of this data structure here, int, times the number of elements, right? Now, a normal integer might take up space that looks like this. Here's a 32-bit integer, and it takes up this much space, right? It's got a bunch of zeros and ones, dot, 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 or whatever value is inside of it. An array asks for a block of memory, right? And one important note about this block of memory is that it is contiguous. It is a contiguous block of memory, which means that every single variable in this array is packed right next to each other. So if this has the memory address of 0x01, just for simplicity's sake, this is the very first element inside of our RAM, right? Then the next variable in here, right, is going to be at what memory address? Well, integers are 32 bits, and remember that our memory addresses are for each byte, for every 8 bits, which means that for this integer, for 32 bits, it's going to take up 4 bytes. And so this next memory location is actually going to be 0x05, because it's 4 bytes ahead in memory, right? Another way to look at this is sort of like if you were to line it up like this, and this might be a slightly easier way to look at it. So here is the position of the array, right? This is the position of A, is right here at this spot in memory, at the very beginning. And we have all these bytes, 0, 1, dot, 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 right? And here is the length of an integer, 32 bits, right? Which is also 4 bytes. Now, memory address 0x01 would be right here at the very beginning. Memory address 0x02 would be 1 byte over, right? So after 8 bits, here's 0x02. And then another 8 bits, here's 0x03. And then another 8 bits, here's 0x04, right? And then another 8 bits would be 0x05. Now remember, these are the memory addresses. They go over every 8 bits, right? The next integer in this array, the one at the next position, would be right here. It just continue using this block of memory, right? Dot, 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 right? So on and so forth. So arrays store their values in a contiguous block of memory, like this, right? All your values are just packed right next to each other, and they're taking up this whole block of memory, right? Now, this is actually really good for us because it means that when I know the value, when I know the position of A, which I know starts right here, and I want to get to A bracket 3, right? Remember that this is actually the 4th element over, right? And we have 5 here inside of our example array. Really what I need to do is, I can do this incredibly quickly, right? Because I know that integers are 32 bits. So when I want to go and look at the 3rd element, it's the position of A, wherever it is, and then plus, I can take that memory address and add on to it 3 times the size of an integer, right? So I can add, I can add 3 times 4, right? And go over that memory addresses, and boom, here I am at my 4th element, right? Which would be right here. Cool. So the next thing that we know how to talk about is A's, an array. A there actually isn't that much difference between an array and a pointer, right? This variable a is just holding a memory address to the beginning of this giant block of memory. And the spoiler for this entire thing is that there's actually no difference between a built-in array in C++ and a pointer. You could actually create an integer pointer, p, and assign it equal to a. That variable a is only holding a memory address. It's holding this memory address. And if you want to access the third element inside of an array like this, there's a couple ways you can do it. One is you could say a brackets 3. This subscript operator, the subscript operator, is just shorthand for doing some simple math to determine the memory address of the location of the value that you want to go to. So here, if I said integer pointer p is equal to a, p would also be equal to this memory address right here. And what's funny is that even though p isn't an array, I could go p bracket 3, and this is completely valid syntax in C++, because there is literally no difference between a pointer and a built-in array, right? It's super cool. The other thing you could do is p brackets 3. You could also say, I want to take the position of p plus 3, and then I want to dereference that position. I don't want to dereference the position of p, which is here at this memory address. I want to go p plus 3 elements over and dereference that memory address. There's no difference between an array and a pointer in C++ aside from the syntax difference. And there's no difference between the subscript operator and doing pointer arithmetic like this in C++.